In this video, we are going to look at a sampling distribution for proportions for AP statistics. So in this example, we have that through the Census Bureau, we know that approximately 64% of all U.S. households have children under the age of 16. We take a random sample of 100 households in GCISD, in the attendance area, and we find that 68% of households have children under the age of 16. If the GCISD attendance area follows the national model, what is the probability we will get a proportion as large or larger than 68? Okay, so for this particular problem, we're looking for a probability. The normal model would be a great way to go about this, but before we can do that, we've got to determine if our conditions are met. So what we're going to do is we're going to write out our conditions over here. So we've got 100 households in GCISD. We are told in the problem that it is a random sample. So a random sample of 100 GCISD households is given. There's a million different ways you could write that. You could say 100 households represent a simple random sample in GCISD. The sample that was taken from GCISD households is 100 and it was random. So many ways you can say that. Okay, it's reasonable to believe that these households are independent of one another. And it's probably reasonable to assume 100 is less than 10% of all households in GCISD. We don't know that for sure because I don't have how many there are, but it's pretty reasonable to assume that. And then of course I'm going to look at my NP rules, because remember, in order to say using normal is okay, my sample has to be big enough based on at least 10 of one category and 10 of the other. So in this case, I am going to take my 100 here and I'm going to multiply it by 0.64. 0.64 is the P that we're using because 0.68 came from GCISD, and we're actually comparing that to the national model, because notice, what is the probability that we will get a proportion as large or larger than 68? So we want to know what the probability is that we'll get 68 if in fact 0.64 is actually the true proportion. So that is what we're going to use for P. And both of these values are bigger than 10, so my sample is in fact large enough to approximate normal. Okay, the very next step we're going to do, because in order to use the probability, we have to have our parameters. So the mean here of P hat is going to be equal to P, which is 0.64. The standard deviation is going to be equal to the square root of P times 1 minus P over 100, and that is going to give me 0.048. So my distribution for all samples of 100 is going to look like that. And now I'm ready to find my probability. So 0.64 is in the center here. 0.68 is right here. I want to know the probability we will get a proportion as large or larger. So I'm going to shade to the right, and I'm looking for the probability that P hat is greater than 0.68. And if you wanted to, you could go into Staplet, you could use your calculator, you can find your z-score and look it up on the chart. All of these are acceptable. So if you use, I don't know if I've got, I don't think I have Staplet open, but we can probably get it open pretty quick. And then we're going to look at a normal distribution. We're calculating an area. Our mean, of course, is going to be 0.64. Oops, it helps if there's a decimal where they're supposed to be. And then my standard deviation, of course, is 0.048. Plot the distribution. I want shading to the right of 0.68. And it is 20.23%. Neato speedo. So 0.2023 or 20.23%. Neato.